My name is Artyom. I'm one of the creators of open source project called Cube. You can find it on GitHub. It's a semantic layer. And later I started a company to build a commercial version of that open source project. Today I will talk about semantic layer as a category and why do we need a standard for it. Semantic layer or metrics layer is sort of a very new category. And when I talk to people about it, it feels we as a data engineering community have a general idea why we need it, what value it gives, but and we understand how it should work when we zoom out. But when we zoom in, it's still a little unclear how exactly it should work, how metrics should be defined, how integrations with BI should work, and with other data consumption tools. And today I will try to talk about it. So in engineering, we quite often separate interfaces from implementation. So today I will talk mostly about interfaces, not implementations, meaning that I will talk about how the semantic layer should look outwards to different data consumption and BI tools. So that's sort of talk and general ideas is the result of many conversations with our community and other companies doing a lot of things in this space. We try to come up to the standard of the semantic layer. But before I go into that, let's start with some basics and a definition of a semantic layer itself. How many people here have heard about semantic layer? It's great, pretty much all of you. But I will still do a quick recap. So when I need to describe a semantic layer in one sentence, I usually call it applying dry principle on a data consumption architecture on scale. So the dry principle, all of that, do not repeat yourself. Sort of the problem that semantic layer is solving is that we have all these different great data consumption tools, BIs, notebooks, embedded analytics, but every time we deploy another tool, we define metrics inside that tool. This way we are repeating ourselves, right? And then what meaning by applying that principle is that let's take all of these definitions from these visualization tools and put them into semantic layer. And define metric once in a semantic layer and then use them across all of these different data consumption tools. From the features perspective, it seems community are sort of arriving at 4 pillars of the semantic layer, as you can see here on a slide. The foundation of everything is a data modeling. It is where we actually define our metrics and data models. Many tools do it differently, but most of the products that are doing semantic layer and our product included do the code first. So we're big believers of doing it the code first because it helps us to apply software engineering principles and ideas to data management, like a version control. But there are still approaches where data modeling can be done in a more visual way. The next pillar is access control or governance. Access control is always connected to metrics definition because you cannot have metrics be available to all organization, all personas. It always would be a requirement, to mask some data or to apply column level, row level access policies. So the access control governance always been really coupled to metrics definitions. The other pillar is caching. Caching gives you the fast access to metrics, not to run the same sort of, a query in your Snowflake twice. And it also potentially can help you to save on costs of an underlying data warehouse. And APIs is a way to deliver these metrics tools, these data consumption, BI tools, visualization tools. It's not only BI tools, but it's really any tool. Embedded analytics should be a big part of it. Custom maps, even AI apps. So when we talk about APIs, we usually talk about a lot of different ways to expose data. From the whole data stack perspective, the way that semantic layer fits into data stack is that it usually sits between one or multiple data warehouses and multiple BI tools or visualization tools. Data in the data warehouse is usually being already transformed with tools like dbt or SQL Mesh. Usually this data being transformed into sort of normalized tables representing entities. And then these tables entities are being transferred to the semantic layer, and semantic layer acts as a denormalization engine, kind of building all the metrics and delivering these metrics eventually to the data consumption layer. Right, so why do we need a standard overall? I think the promise of the semantic layer, if we think about it, is to deliver metrics to all these downstream tools. It means that semantic layer needs to work very well with all the possible sort of a different visualization tools. And for developers of the semantic layers like we at Cube, right, it means that we need to support the ever-expanding set of different technologies because our customers community comes and asks for that support. And for BI tools, on the other hand, they would need to be able to support multiple semantic layers. And that's where, like traditionally we can see it in other industries, standardization can help. Let's zoom in and to think about how semantic layer can work with one specific tool, Tableau. So we obviously can build one-to-one connector, but the problem is that the BI market is very fragmented and there are so many different BI tools, and it would be almost impossible to build one-to-one connectors to all of them and maintain them. Well, I mean, there are so many BI tools, that's why we have a semantic layer in first place, right, to solve that problem. So now if I try to formalize the problem it would be how to bring an experience of the integrated semantic layer to the decoupled architecture. And let me first define integrated semantic layer and decoupled architecture. So many of you may know Looker. Looker is probably one of the best examples of well-built integrated semantic layer. The fact that LookML was sort of a key to the success of Looker itself, right? So when we do something in LookML, which is a code first, right, we can define objects like explorers. And then we go in a UI and Looker and we see that explorer in a drop down. That's what I mean by integrated, right? Like every our change in a semantic layer, it sort of influence and is being reflected in the UI of the BI tool itself. Now the question, if semantic layer is decoupled, right? Meaning that it's being a separate standalone tool, standalone product, and it's most likely being built by a different vendor too. How we can make sure that we can get to the same level experience of a Looker, right? How we make sure that if a data team defines metrics in a semantic layer, and then your data consumer would go to a BI tool, they will see that list of the metrics, they will see that objects, right? Because all the BIs, they have their own sort of native objects they use, like Superset has data sets, Tableau has data sources, Power BI has a lot of like interesting things with DAX and all of that, right? They all have their native objects, but the question is like how we make sure that they being integrated with the semantic layer, so data consumers just use their native objects. So, and I argue that the standard will help to align visualization tools and semantic layers to achieve a user experience similar to integrated semantic layers, especially on a scale, because again, one semantic layer needs to support multiple data consumption tools and vice versa. Data consumption tools need to be able to work with multiple semantic layers. Let's talk what this standard might cover. So, and again, we will talk about interface, not the implementation, right? Because different vendors can do a different implementation as long as the standard can cover the interface. So the standard generally, I think, should include the specification of objects to describe semantic layer. We can talk about metrics, which are aggregated expressions on top of columns, but we also should think about non-aggregated values on top of entities. Like, for example, the order has value, customer has a date when they need to renew. Querying protocols, how exactly BI is going to query, right, our semantic layer, how this embedded analytics is going to query semantic layer. That's part where like we can talk about querying protocols. And finally, metadata API. how the BI or data consumption tool will get all of these objects out of semantic layer and make sure that they have their native objects being mapped correctly to the semantic layer. So let's first cover objects to describe the semantic layer. So far, we've seen mainly two approaches to that problem. One is, I would call it a metrics first, and a second is a data set first. So let's first is metrics first. In metrics first, a metric is a first class object, right? That usually has a time dimension and a set of dimensions connected to that metric. In that case, semantic layer would be exposed as a list of metrics, and data consumer will use that list of the metrics as an entry point. So for example, if I want to look at the average order value metric, I would go to my list of metrics, find that metric, and start my analysis with that. I would most likely look at it monthly or quarterly, so I will apply time dimension. Maybe I will do breakdown by state, a country, I could do a different dimension, but that's how the flow might look like in that approach. Let's look at the pros and cons of that. So the upside is that that's how we usually think about the data, because metrics sort of are very natural to how organizations operate. We set them as goals, set them as KPIs. So we talk about metrics. So it means the idea of metric, it would be easier to communicate within organization. The downside here is that most of the data tools don't have idea of metrics. When we talk about sort of, like user experience of the integrated BI, right? Integrated semantic layers. Because most of the data tools, they think in tables, cubes with measures, dimensions, right? If we would go to any BI tool, they usually have that concepts. Some of them are adding metrics. There are some of the new generation visualization tools that are being a metrics first, but in general is that data tools work with a tabular data, not metrics. The other sort of unclear question would be how we're going to deal with non-aggregated values and how they're going to fit into that model. So for example, we don't want it to look at the average order value, but we wanted to look at order value of the specific order. If we expose metrics as a top level object, where that value should go, that's clearly dimension, right? But where that dimension should go, that's a little unclear. Let's look at the datasets first. Dataset is essentially tabular based. It's a table that describes an entity. Columns might be measures, one or multiple measures. Can also be dimensions, including time dimensions, and rows would be distinct entities. In that case, if the sort of exposed semantic layer would look like a set of tables, and data consumers would use that list to start working with the metrics. So in that example, if I would want to look at the average order value metric, I would probably go to a list of my data sets, search for orders data sets, go inside that data set and look for the average order value measure inside that data set, and then apply all the corresponding kind of dimensions and time dimensions. So pros and cons of this approach, they're a little bit upside down compared to the metrics first. So the downside is that it's harder abstraction to comprehend, because we're dealing with the data sets, we're dealing with the tables, but because they have measures, they're essentially multidimensional, and that means it would be harder, for people within organization to understand, obviously, rather than metrics. The upside, though, is that BIs are generally, pretty familiar with the idea of tables and cubes, right? So that approach would be easier to map to tools like Tableau, Power BI, and the rest of the BIs that people commonly use. So if we can look at these two approaches, we can try to get the best of the two worlds, which might give us an opportunity to combine data sets with metrics. In that case, metrics potentially can be a special case of dataset-centric approach, where we deal with a table with only one column, where only one column is table is a measure, and the rest of the columns are dimensions. Thinking about that, we are sort of putting metric into the table box as a container and use it as a transport across multiple BIs. This way we can combine the entity modeling with a metric modeling even within a single project, and maybe we can use it for different personas or for different use cases. The entry point will still be tables, list of tables, but using a proper naming convention, we potentially can separate entities from metrics and use them together. Let's go. I'm just checking the time here, so I need to stop in 5 minutes. Let's talk about querying protocols. So semantic layer should provide a full-fledged querying interface to fulfill that promise of like delivering consistent metrics to all data consumption tools. So we need a way to actually bring data right to all these tools. So currently, I think most of the tools use SQL. Most of the data tools use SQL, right, to query the data from a cloud data warehouses. So SQL feels like an obvious choice, right? Semantic layers, they should expose SQL as an interface. Also, I mentioned that embedded analytics, so like different ways to use data should be sort of an instrumental part of the semantic layer. And that seems the GraphQL seems to be the right approach. Like a REST API, GraphQL API style seems to be like a right approach for HTTP-based interface. And then it's I have it here at Power BI. It's an interesting question about MDX. We all know that MDX is very popular within Microsoft ecosystem, not much outside of it. But then the question is like, does it mean that semantic layers need to support MDX and expose that endpoint? Or like we don't care about it because it's only within Microsoft ecosystem. But then Microsoft ecosystem is too big, right? Like to ignore it. So that's an open question, and I think like it's an interesting question to learn whether the Microsoft ecosystem will become more friendly with the SQL or semantic layers will start to kind of expose more MDX. But let's talk about SQL specifically, because that's where things might get a little tricky if we wanted to query metrics with SQL. So it's obvious we want to use SQL as a transport, but then we have two options. One option I call is a big scale extension. So big scale extension is essentially using SQL as just a wrapper and embed our own metrics querying language inside a SQL. The benefit of that approach would be is we can design our own language however we want. It's going to be very native to query metrics or whatever constructs we have. But the problem is that it's going to be hard for the BI tools to generate, because right now BI tools, they generate a SQL to get the data and then don't know how to generate that specific SQL. So we're sort of using SQL, but we're not really using SQL. And that might be a challenge to implement support with different BI tools. The other way, which I call here a small scale extension, would be an idea to extend SQL with few minor changes that potentially can help us to support SQL, sort of querying metrics in SQL. So if you think about SQL, it's a very tabular table based, right? Like we always querying table with a SQL. The problem though is that we don't have idea of a metric in a SQL. And if I try to define for SQL specifically how we would define a metric, it's probably would be a spatial column that knows how to evaluate itself. So the rules, how to evaluate itself, the predicates, expressions, or ratio, that should be designed inside the semantic layer, obviously, right? But on a SQL level, we should be able to tell, hey, this is a measure, just evaluate it. So that means that probably SQL needs some sort of a measure type level where we can say this column, this is a measure, and then the aggregate function that can query that measure. So that I would call a small level extension to SQL. It still might sort of cause potential issues when implementing, because it might, the SQL is not designed really to query metrics, but that seems that approach that potentially can work. And I know I don't have any time, so I'll just try to fit it into 1 minute, the metadata. that's a part where I was talking about Looker and, like Explore appearing in a dropdown, how we make sure that it actually can happen. So I believe that semantic layers need to come up, like with a single standard in terms of how they expose their data. Once we figure out, okay, is it a dataset centric, the metric centric, what is objects definition, we can expose these objects through some sort of API. And then this API will enable BI tools, anyone to build a sort of consumers that can just get all this data and map it to the native objects. We obviously will have sometimes a push option, right? Like where a semantic layer will push the definition. Sometimes it's going to be a pull option, but essentially that's the idea where we need this metadata standard API so it can be, like standardized across all the different tools. And with that, I think I have to stop now. And please, if you want to chat more about it, you can meet me here or at our booth. I'm with Cube. We have a booth located in Activation Hall. So, like myself or our team would to talk everything about semantic layer. But to summarize, we just wanted to start that conversation and, so we as an industry community can come up with a standard that will help data visualization tool, BI tools, and semantic layer vendors to build just the better futures in terms of providing really good integrated experiences. Thank you, everyone.